Today we're going to graph some quadratic functions. So we're going to see a couple of different forms of quadratic functions. The first form we're going to see is a quadratic that looks like this, where I have a number outside of parentheses where I have x minus a number squared plus a number. For example, f of x is equal to 3x minus 2 squared plus 4. So this is one particular way of viewing a quadratic function. Here my a is 3, my h is 2, and my k is 4. When you have a quadratic function set like this, you can tell some really important information pretty quickly. One is the vertex. So the vertex is the minimum or the maximum of a quadratic function. Remember that a quadratic function is either going to look like this or this. So that's called a parabola, and you're going to have a minimum or a maximum. The minimum or maximum is called the vertex, the lowest or highest point in this particular graph. If you're given this form of a quadratic, the vertex is h comma k. Now, another thing to notice about parabolas is that they're symmetric. And they're symmetric with respect to this vertex here. So whatever's on this side of the vertex, the mirror image is on the other side. And this x value, or we can draw a straight line through the x value of that vertex, is called the axis of symmetry. So x equal to h is the axis of symmetry. And that'll help us draw the picture of the quadratic function. Another thing to notice is that this number in the front, a, tells us if the parabola is pointing upwards or downwards. If a is greater than 0, we're pointing upwards. If a is less than 0, we're pointing downwards. So pointing upwards like this, and pointing downwards like this. It also tells us if we have a minimum or a maximum. So if we're pointing upwards, our vertex is going to be the minimum of the graph. And if we're pointing downwards, the vertex is going to be the maximum of the graph. Another form of a quadratic that you will see is the general form, which is f of x is equal to ax squared plus bx plus c. The vertex for something like this is given by negative b over 2a and f of negative b over 2a. So the h value of the vertex, you're going to take this number in front of the x, multiply it by negative, and divide by 2 times this number in the front. And then to find the k value of the vertex, you're going to take that number you found here and just plug it into this equation. And then you'll find the k. And the axis of symmetry is still going to be x is equal to h, just like before, except for to find this h is negative b over 2a. And this number in the front, this a, is the same a as in the last set of the quadratic functions. If a is greater than 0, we're pointing upwards. And if a is less than 0, we're pointing downwards. Okay, I think we're ready to look at some examples. Now here I'm giving you a quadratic. F of x is equal to x plus 2 squared minus 2. The first thing I want to do is I want to put this in the general form. just so that you can see what you need to do to get to the general form. So notice that if we square this, we get x plus 2 times x plus 2 minus 2. So f of x is equal to x squared plus 4x plus 4 minus 2. That's just foiling this out. And then we have, when we simplify it, is x squared plus 4x minus 2, plus 2, sorry. Okay, let's figure out a few pieces of information. Let's find the vertex. So the vertex, now this form here, let me circle it in green, is the form f of x is equal to a x minus h squared plus k, where the h is the opposite of what you see in here. So the h is negative 2. Because remember, the vertex is h comma k. So let me put vertex is h comma k. Here I have a negative. A plus 2 is the same thing as a minus negative 2. So that's where I'm getting this negative 2. Always take the opposite of what you see here. But for this one, you can keep the same sign. So negative 2, negative 2. So let's put a little dot here at negative 2, negative 2. That's the vertex. So it's either the minimum or the maximum of our graph. Some other pieces of information. So let's double check that the vertex, first off, that we get the same vertex by using the other form. So we said the vertex is negative 2, negative 2. Now let's focus on this form right here. So let's say I gave you this part, this equation instead of this one. So the vertex should be the same, right? So the vertex, remember, is negative b over 2a, comma, f of negative b over 2a. Well, b is 4, so h is going to be negative 4 over 2 times the coefficient in front of the x squared, which is 1, but you can see that is negative 2. So this piece is negative 2, just like we knew before. Now let's find k, this piece here. So k is taking negative 2 and plugging it into the function. So let's do that. So if we take negative 2, square it, add 4 times negative 2, and then add 2, we get 4 minus 8 plus 2. This is negative 4 plus 2, which is negative 2. And you can see that my x and y values for the vertex, which we're labeling h and k, are the same thing no matter what formula I use. So when we have something set up like this, we just do the opposite of this one and keep the sign of this one. This form is really, you can find the vertex really quickly just by looking at it. So when you're given this form, this is the best form to have because you can find the vertex quickly. But if you're given this form, that's okay. You can use the vertex formulas I gave you, like finding h and k, to find the vertex. Okay. All right, let's talk about a, the number in front. Notice that the number in front here is a 1. And also when we FOILed it out, the number in the front is a 1. So those two line up. So a is 1, which tells us that our parabola is pointing upwards. So we should be pointing this way. Now we have an axis of symmetry. The axis of symmetry is this x value. Remember, x is equal to h. And the h value is negative 2. That's our axis of symmetry. So if I draw something over here, I'm going to have the same thing on this side. So we need to find one more point. I think the easiest thing to find is the x-intercept. So what I'm going to do is I'm going to figure out where we cross this x-axis. And how you do that is you set the equation equal to 0. So 0 is equal to x plus 2 squared minus 2. And then I'm going to move the 2 to the other side. Then we can take the square root of both sides. So we get x plus 2 is equal to positive negative square root 2. So you see that x is equal to negative 2 plus or minus root 2. Now, this is really hard to graph. So maybe instead we can, see, my idea was to, if it came out to a really nice number, I just, like, let's say it was 1, I could put a point here, and then I could put another point, because it's symmetric, I could put another point over here. But that didn't happen, so we're not going to use the x-intercepts. Instead, let's plug in another value for x. Let's stick to something small. So let's say when we plug in, I could put in 0. Yeah, let's plug in 0 for x. So if x is equal to 0, then f of 0, I'm plugging that into this equation, you can plug in this one as well, is equal to 0 plus 2 squared minus 2, which is 4 minus 2, which is 2. So we have the point 0, 2 on the graph. So let's graph that. At 0, 2, here's the point. And because we have this axis of symmetry, well, first off, we can go ahead and start sketching this graph. It looks something like this. And we're also going to have the point negative 4, 2. Because you see, whatever's over here, this distance is 2. I also have a distance of 2, and I have a dot here. So then you just draw the other side of your graph, which should be symmetric. So something like that. And you can double check this. Let's plug in negative 4 and see if we actually get 2. So f of negative 4, we plug it into here. We have negative 4 plus 2 squared plus, minus 2. This will be negative 2 squared, which will be 4. So 4 minus 2 is 2. So we do have the point negative 4, 2 on the graph. So now I have a good sketch of my graph. Now the question is, how do we go back? If I give you this form of the equation, how can I put it in this form? And also notice that instead of just plotting it the way I have, I can do transformations of functions. So the parent function here, in fact, let me erase some of this so you can see it. So I'm going to erase this and focus on this form here. This looks like the parent function y is equal to x squared, right? So y is equal to x squared goes through these 3 points and looks something like this. We learned that a long time ago, well, a few weeks ago. And then how do we take this parent function and make it look like this one? Well, one thing is we plug in, if this is y, in fact, let's call it something else. Let's call it g of x. We can define this new function g1 of x, and that's just taking g and plugging in x plus 2 inside. And you'll get x plus 2 squared. And remember that this corresponds to shifting the graph left and right. So we shift it to the left 2 units. So all of these points are moved to the left 2 units. So something like this. And then the next step is to take care of this negative 2, which we define this new function g2 of x. And we take g1 of x and we shift it down 2 units. So 1, 2, and this point will be shifted down 2, and this one will be shifted down 2. And so you can see that we get, if we drew the parabola connecting these 3, will lie on top of this same graph. So I've given you a couple of options on how to graph this. You can use transformations of functions when you have something set this way. So shifting up and down, left and right, and then also if you have a number in the front that stretches or compresses the graph. Or you could do the other option, which is to find the vertex, figure out if the graph is pointing up or down, and then find another point on the graph. And using the axis of symmetry, you can make a mirror image and then graph it. Okay, let's look at another example. Here I have f of x is equal to 3x squared plus 6x. Okay, this is not in the form where we can look at it and tell the vertex really quickly, which that is the form f of x is equal to a x minus h squared plus k. So it's not in this form, but it is in the general form, which is ax squared plus bx plus c. You can see that a here is 3, b is 6, and c is 0 because there's nothing on the end. Let's find the vertex. That's h comma k, where h is negative b over 2a and k is f of negative b over 2a. So to start with h, negative 6 over 2 times a, which is 3. That will give me negative 6 over 6, which is negative 1. And then to find k, we plug in negative 1 to our function. So plugging in negative 1, so f of negative 1 is 3 times negative 1 squared plus 6 times negative 1. So we'll get 3, because this is just going to be 1 here. 3 times 1 is 3, minus 6, which is negative 3. So my vertex is negative 1, negative 3. Let's plot that. Negative 1, negative 3. Now, is the graph pointing up or down? Well, we look at the number in the front, which is 3, and we see if it's greater than or less than 0. Since a is greater than 0, we point upwards. We also have the axis of symmetry. The axis of symmetry is given by x is equal to h, which is negative 1 in this case. So this is the axis of symmetry, which tells us if I can find one more point on this graph, let's say it's on this side, then I'm going to have a mirror image on this side. All right, we need to figure out another point on the graph. So what point should we use? Now you can use any point you want. This time, I think this function factors easily, which makes me want to use the x-intercepts. So if I set this function equal to 0, let's factor it. I can factor out a 3x and I'll get x plus 2. And if I set each piece equal to 0, I get x is 0 and x is negative 2. So my two x-intercepts are 0, 0 and negative 2, 0. You can see that the mirror image of this one is right here. I only needed to find one and I could have found the other one, but setting it equals to 0 gives me both of them. And now I can graph this. It is pointing upwards, you can tell, and you can actually find more points if you want to. But you really only need the vertex and one other point, and then you can find the mirror image. You can see that this graph is kind of skinny, and that's because of this 3 on the outside. The 3 compresses the graph, or I guess you could say stretches it upwards, or you could think of it compressing it in like this. So it goes this way, or you could think of stretching it like this. Okay, so now we have a picture of the graph. How can we put this into this form? Actually, this is very easy. Now that we know the vertex we said was negative 1, negative 3, which this is h, this is k, and remember this is a here. So to switch to this form, I needed a, h, and k. So all we have to do is say that this is equal to 3 x minus a negative 1 squared plus a negative 3, and I can clean that up a little bit. This is 3x plus 1 squared minus 3. So I switched to this form here, and I could use transformations of graphs to graph this. So this would be taking the parent function, moving it to the left 1, and then stretching it by a factor of 3, and then moving it down 3. So you could follow those rules. So take the parent function, move it to the left 1, stretch it by 3, and then move it down 3, and you get the same graph. Okay, now we're going to look at some problems from the homework. Now you have some problems that are very similar, but these are from the book, and I think I gave you odd problems, and these are some of the even problems. So it says in these problems, graph the function f by starting with the graph of y is equal to x squared, and using transformations, graph this function. So if necessary, write f in this form, because this form is very helpful in graphing. All right, so I have been given this function f of x is x squared minus 6x minus 1. And I want to graph it using these transformations. I'm going to write it in this form because this will help me use transformations. So how do I get it in this form? Let's write what a, b, and c are, because this is actually in general form. So a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the number without any x's. We need to figure out what a is, what h is, and k is to put it in this form. So a is 1, so we can just put a 1 here. To find h, remember when we're in this form, the vertex is h comma k. So h is negative b over 2a, and k is f of this negative b over 2a. So h is negative of negative 6, which is a positive 6, over 2 times a, which is 1. So I get 3. So that's my h. And then I'm going to plug 3 into this function. I'm actually going to, so I want to get some space, I'm going to erase this. So k is equal to f of 3, which is 3 squared minus 6 times 3 minus 1, which is 9 minus 18 minus 1. Okay, just make sure I didn't do anything incorrect. Okay. And then I have negative 9 minus 1, which is negative 10. So the vertex is 3, negative 10. Since we have the vertex, let's put it in this form now. Okay, dokie. So we have f of x is equal to a, which is 1, x minus h squared plus a negative 10, or plus negative 10 is the same thing as minus 10. So this is the form. And now using this form, let's graph our function. So if we start with the parent function, y is equal to x squared, it looks like this. What do we have to do to get y is equal to x squared to look this way? Well, this negative 3, if we plug it in, we move the graph 3 units to the right. So 1, 2, 3, all of these get moved 3 units. Okay. And then what else do we need to do? Then we need to move the graph down 10 units. Now this goes down 6, so 7, let me just continue this down a little bit, 8, 9, 10, and we go down here. And then we can just move this point here and this point here. And so the graph is going to look something like that. And the axis of symmetry is x is equal to 3, which is the h value. And you can see whatever's on this side would be flipped on this side as well. Now you don't have to use transformations to graph this. Remember, all you really need is the vertex and another point. Let's try using transformations again with this function here. We have f of x is negative 2x squared plus 6x plus 2. So to use transformations of functions, I want to get this into this form. Let's write out what I do know. I know that a is negative 2. I know b is 6 and c is 2 because this is ax squared plus bx plus c. To find h, we've already got a. To find h, we do negative b over 2a, which is negative 6 over 2 times negative 2. So negative 6 over 2 times negative 2, which is 6 over 4, negative 6 over negative 4. I just got rid of the negatives, which we can reduce to 3/2, which is 1.5. The reason I want to say 1.5 is that's going to make it easy to graph. So 1.5 is here. So we need the y value. This is the x value though. Okay, to find k, we plug in the function into the function 3/2. So this is negative 2 times 3/2 squared. I'm just plugging it into here, plus 6 times 3/2 plus 2. Okay, square this, we get negative 2, 9 over 4, plus, so I could simplify this, but I think I'm going to leave it over 2 because I'm going to have to add these fractions. So I've got 18 over 2 plus, I'm going to make this 4 over 2, just because I want to have the same denominator. Okay, and so this goes into 4 twice, so I get negative 9 over 2 plus 18 over 2 plus 4 over 2. Negative 9 and a positive 18 make a positive 9, 10, 11, 12, 13. I get 13 over 2, which is 6.5. Okay, so the vertex is at negative, positive 3/2 and 13/2, so 6.5, we said, which is right here. So that's our vertex. Let's put that down. So vertex is 3 over 2, 13 over 2, and we can write it like this as well, 1.5, 6.5. Okay, now the graph A is negative, so it's pointing downward. So we should expect that here, pointing downward. Now the objective is to use transformations of graphs to graph this. So let's write this in this form. We've got negative 2 x minus 3/2 squared plus 13 over 2. And remember, what goes in here is always the opposite of what you have here. Okay, so this is our function. So let's graph it using transformations of graphs. So we start by using the parent function. Okay, let me do these in green. So this is the parent function. Oops. Y is equal to x squared. Now, how do I get y is equal to x squared to look like this? Well, the first thing I can do is I can there's a lot of things I can do. So if y is equal to x squared, I want to go ahead and shift it to the right 3 over 2 units. So I can make it y is equal to x minus 3 over 2 squared, which means move over 1.5, which is right here. So this moves over 1.5, and this one moves over 1.5. So let's erase this and draw a new graph. I would like, because I need to stretch this graph, I want to figure out what one of these points is. So remember that we moved it over. This is 3.5, so this would be 2.5, comma, we went up 1, so 1. And we can check this. We can plug this point into y is equal to x minus 3 over 2 squared and see if we get 1. So this is 5 over 2. 2.5 is the same thing as 5 over 2. If you subtract 3 over 2, that's 2 over 2, which is 1, and square it, you get 1. So this is the point here, 2.5 comma 1. The reason I did that is because now I want to stretch this graph, and to stretch it, because I have this negative 2 on the outside, to stretch it, I need to multiply my y value by negative 2. So this point 2.5 has to be multiplied by negative 2, which means I reflect the graph and I move it to negative 2. So what's going to happen, this point, if I reflect the graph and then move it to negative 2, I'm going to have the same thing on this side here. So now this is y is equal to negative 2 x minus 3 over 2 squared. I'm using transformations of functions here. And I also want to put this point here, which is 2.5 comma negative 2. Okay, let's erase this. And the last step, so this graph is almost what I want. I just need to move up 13 over 2. And if I move up 13 over 2, I go right here, right where I want it to be, which is the vertex I had. And then this point needs to go up 13 over 2. So let's see. So we move up 6.5. So this needs to move up 6.5. Or, okay. So that's 2, 4, 6.5 right here. Let's be very careful. So move up 2, 4, 6. That will be 7, yeah, 6.5. So then this point is 2.5 comma, this looks like 4.5. And our axis of symmetry is right here. And you can see that's 2 over, so we'll have a point here. Okay, so now we've drawn our function using transformations of graphs. Let's double check this point just to make sure that I have the right point. So this is 5.5 and this is 9 over 2. If I convert these decimals to fractions, so if I plug 5.5 into my function, I should get 9 over 2. Let's see, so I'm going to plug it into here. So f of 5 over 2 is negative 2 times, so 5 over 2 minus 3 over 2 is 2 over 2, which is 1 squared, plus 13 over 2. So I get negative 2 plus 13 over 2. This is 4 over 2 plus 13 over 2. I do get 9 over 2. So this is correct. I just wanted to double check that my work was correct. So, okay. Yeah, transformations of graphs is not easy, especially when the a value is not equal to 1. That's when it gets tough because you have to stretch your graph. So I don't think the best way to graph this is using transformations of graphs. What I think is the best thing to do is just to find the vertex, find the axis of symmetry, determine if your function is pointing up or down. And then after you do that, you just need to find one more point, and then you can find, because from the axis of symmetry, you can find another point in the graph, and then you can graph this thing. So that's what we're going to do in the next few problems. So in problems 33 through 48, which we're just going to do 2 or 3 of them, graph each quadratic function by determining whether it opens up or down, finding its vertex, its axis of symmetry, its y-intercept, and its x-intercepts. So they actually want you to find more points, and it'll tell you more about the graph. Determine the domain and range of the function, and determine whether the function is where the function is increasing and decreasing. So we've got a lot of stuff we need to figure out. A lot of this can actually be figured out without even graphing the function. I'll show you how to do that as well, but we're going to do each piece. So first, let's find the vertex, okay? So how we do that is, this is in general form, ax squared plus bx plus c. A is 1, b is 6, and c is 9. Okay, h is negative b over 2a. So that is equal to negative 6 over 2 times 1, which is negative 3. K is f of negative 3, which is negative 3 squared plus 6 times negative 3 plus 9. This is 9 minus 18 plus 9. I feel like we've seen these numbers so many times. Okay, so we get negative 9 plus 9, which is 0. Very interesting. So our h value is negative 3, and our k value is 0. So this is our vertex. Okay, let's plot this. So negative 3, 0 is right here. So that's our vertex. So it's either going to be a minimum or a maximum. And how we figure out which one it is by looking at A. It is pointing upwards because this number is greater than 0. So just to get an idea, our graph is going to look like this. Okay, so we found our vertex. I'm going to erase this so I can have a lot more room. Now, something else that we wanted to find. So let me cross out what we found. We found the vertex. Let's find the axis of symmetry. And the axis of symmetry is just the h value. So x is equal to this h, which is negative 3. And we just draw a dotted line here to help us draw a symmetric graph. So that's the axis of symmetry. X is equal to negative 3. It's not part of the parabola. It's just helpful when we draw this graph. So we've done that. Let's find the y-intercept and the x-intercepts. Okay, so I'm going to erase this. And let's focus on the x-intercepts. So remember, x-intercepts is where we plug in 0 for y. Is it factorable? Yes, it's x plus 3 times x plus 3. So x plus 3 squared. So the only x-intercept is negative 3, 0. The vertex, it makes sense that we only get one of them because remember, you only have one point for that vertex. So you only get 1 point, which is good. So that's the x-intercept. Let's find the y-intercept. So the y-intercept is when we plug in 0 for x. So f of 0 is 0 squared plus 0 plus 9, which is 9. So 0, 9 is the y-intercept. Okay, so I'm going to have to go up outside of this. So 7, 8, 9, 0, 9 is the y-intercept. So that tells us that the graph looks like this. But remember that this graph is symmetric and we had to go over 3 units to get to 0 from negative 3. So we're going to go over 3 units, 1, 2, 3 to negative 6 and go up 9. And then our graph is going to go through that point. So now we've graphed this. Now let's figure out the domain and the range. Now you can look at the function to figure out the domain and the range, or you can look at the graph. Because for a quadratic, there are no fractions, there are no square roots. That means the domain is all real numbers. And that's going to be true for all quadratics. The range is how up and down you go. Notice that in this graph, the lowest y value you have is 0, because that's where the vertex is. And we go up here. So we go from 0 to infinity. But you could also figure this out without graphing it, just by looking at the vertex and knowing that your graph is pointing up. Then if the graph is pointing up, that's your minimum value. The minimum y value was 0 because this point is -3, 0. So because of that, that would tell you that the range is going from 0 to infinity. The other part of this was to determine whether the function is increasing, where it's increasing, and where it's decreasing. So looking at the graph, you can see this. We are decreasing. Remember, think of your car going from left to right. You would have to go down and then up here. So we're decreasing from -infinity to this x value of your vertex, -3. And I believe some textbooks use a parenthesis here and some use a bracket. And I believe your homework wants you to use a bracket. If that doesn't work, put a parenthesis here. And then we're increasing from -3 to infinity. And again, you don't actually have to look at the graph to figure this out. You know the vertex is a minimum. So if it's a minimum, then from -infinity to -3, you are decreasing, and then from -3 to infinity, you're increasing.